Welcome everyone, and thanks for joining us with this a presentation on Australian dataspaces. Today the focus is on how we're advancing a national approach to trusted interoperable dataspaces to strengthen Australia's research, innovation and digital infrastructure landscape. Today the aim is to share what's been learnt so far on the dataspace journey, especially how these ideas are taking shape here in Australia. We'll start with a quick overview of what dataspaces are and the value they can bring to the research and innovation ecosystem. And then we'll move into key insights and lessons from the pilot projects and what they mean for the future development of dataspaces in Australia. To begin, let's unpack what actually is meant by a dataspace. So a dataspace is essentially a trusted digital environment that enables secure and controlled data sharing, built around three core principles, including data sovereignty, which is about giving data owners real control over who uses their data and for what purpose. Trust is a central theme, supported through strong governance, certification processes and compliance frameworks, many of which draw on international standards from the International Dataspaces Association, or the IDSA. Another key focus is interoperability. So dataspaces are designed so organizations can share and use data efficiently across technical, legal and organizational boundaries using standardized protocols such as the Dataspace protocol, so systems across different organizations can communicate and exchange data seamlessly. It's worth noting that data sharing itself is not new. Data's been shared in different ways for decades, as we all know, and the figure of this slide shows that journey and how data sharing mechanisms have evolved over time. On the left side of the diagram, it starts with a simple one-to-one data exchange, often ad hoc arrangements between two parties, and over time this has evolved into more structured approaches, firstly through centralized data repositories and later through centralized metadata hubs. Dataspaces add a new layer of collaboration through a federated model where multiple participants can share data while working together under common governance rules. In the figure, the y-axis shows added value and the x-axis shows complexity. So as we move towards more federated and collaborative models, the potential value increases, but so does complexity, especially around governance and coordination, highlighting both progress and the challenges ahead. This slide, kindly shared by the collaborators at IPA Japan, neatly illustrates how dataspaces differ from traditional platform-based data sharing models. So on the left, most conventional platforms use a centralized management architecture where a single platform manages all users and data access, leaving participants with limited control over who uses their data and how it's used. In contrast, dataspaces introduces a federated structure where each organization or participant retains full autonomy over their data, so they can define their own usage policies, maintain visibility over data access, and decide exactly who can use their data and for what purpose. Many organizations have historically been hesitant to share data because of concerns about control, use and trust. Dataspaces addresses these issues by empowering participants with greater transparency and governance, and creates an environment where data sharing becomes both trusted and sustainable. So dataspaces offer a modern way for organizations to connect and exchange information without merging everything into one single system. Rather than defining a rigid structure in advance, each party keeps data in its own environment and shares it only when required. This reduces effort and supports genuine data authority because control stays with the data owner. So why would an organization get involved in dataspaces? You'll hear a lot of the focus around dataspaces is only about the technology. But participating in a dataspace is really about unlocking collective value that no single organization on its own can achieve. most industrial data currently is never used because organizations lack trust, interoperability, and control over how their data is being used. Now, Dataspaces build trust by providing clear governance frameworks that give participants the confidence that their data will be used responsibly under agreed terms with transparent oversight. And it enables secure collaboration even amongst competitors or across sectors. Secondly, they enable greater interoperability and efficiency. So instead of managing multiple one-off data agreements, organizations can work within a shared framework that simplifies data exchange and it reduces the duplication of effort. And thirdly, Dataspaces opens new innovation opportunities by connecting data from different sources. For example, you can have industry, government, and research merging their data to generate new insights, products, and services that would otherwise be out of reach. And finally, Dataspaces strengthens an organization's strategic position as early adopters gain experience with emerging standards, help shape governance models, and place themselves at the forefront of national and international digital infrastructure initiatives. In short, Dataspaces are not just a technical project, they represent a strategic investment in future data-driven collaboration and competitiveness. If we look at the growth of Dataspaces over the past few years, the slide sourced from the Dataspaces radar, so this slide tells a striking story. In January 2022, only 87 Dataspaces were recorded worldwide, but by July 2025 that number had grown to 231, showing a remarkable exponential increase in a very short amount of time. The key observation from the exploratory study is that there's still no recorded Dataspaces originating from Australia, with most activity occurring in Europe and other parts of the world, where Dataspaces have gained significant traction. The figure also distinguishes different levels of maturity, from early exploration to preparatory phases, right through to fully implemented and operational Dataspaces, particularly in Europe. A strong example is Catena X, one of the leading operational Dataspaces in Europe, which has made significant progress in building scalable infrastructure and in integrating evolving community requirements into its design and deployment. So throughout this journey, a common request has been for concrete examples, real-world use cases that show how Dataspaces are being implemented globally. So the IDSA has created an excellent online resource that brings these examples together. On their website, it's possible to explore a wide range of Dataspace initiatives from around the world, along with detailed use cases demonstrating how the different sectors are applying the concept in practice. So this slide includes the links for anyone interested in exploring that further, with examples from health, environment, mobility, and more, demonstrating how Dataspaces are being used to address real-world challenges and creating value across diverse domains. Now, this slide addresses a question that often comes up: how do Dataspaces and trusted research environments relate to one another? So people frequently ask whether they're different or whether they can work together. To explore this, we held a joint discussion at a recent conference, and the session was called "Are Dataspaces Already Here in Australia?", where the relationship between TREs and Dataspaces was examined, recognising that each has its own strengths and purpose. So as part of that session, a mapping exercise was carried out. So on the left is the widely used 5 SEAF frameworks for TREs, and in the centre are equivalent concepts from the Dataspace framework, particularly from the reference architecture model, the RAM, and the IDSA rulebook. So to test this in practice, the team considered a real-world use case, the key point project from QSIF to see how Australia's existing data capabilities could be leveraged to support dataspace development rather than starting from scratch. And that work showed that dataspaces can play a complementary role in connecting TREs across different organisations. For example, if 10 TREs are operating independently, connecting them through dataspace connectors can enable secure governed collaboration across those boundaries. Now we'll shift the presentation towards the architecture and building blocks of dataspaces. So this slide shows the overall architecture of a dataspace and how the different components connect to enable secure data sharing across organizations. So on the left of the diagrams, the data provider, the organization that wants to share data, and on the right is the data consumer. So that's the party wanting to access and use that data. The process starts when the provider publishes data or offers it into a data catalog, so often referred to as a broker in database architecture. Alongside the dataset, the provider includes usage policies that outline conditions for access, licensing, or privacy, which are covered later on in the presentation. So a critical element here is the dataspace connector, and that acts as the communication bridge between organizations. So these connectors can be thought of as like electrical sockets. Just as sockets let devices plug in and safely transfer current in electrical parlance, dataspace connectors let different systems connect and exchange data securely and consistently. So once the data offers are published, the data consumer browses the catalog to find dataspaces that meet their needs. When a suitable dataspace is found, the consumer sends a request to the provider and a contract negotiation process begins. If both parties agree to the defined policies, then data exchange takes place under the dataspace protocol, which standardizes how this transfer occurs. Trust and transparency are supported by two additional components. The identity provider, or the DAPS server, ensures that only verified and trusted participants can join the dataspace, or the clearinghouse monitors and records each transaction, keeping a detailed log of when data was accessed, by whom and for what agreed purpose, and that maintains transparency and accountability. Now this figure comes from a recent IDSA connectors report and helps explain how interoperability is achieved while avoiding news silos across organizations. So at the center is the database protocol, the DSPR, whose main purpose is to provide a standardized communication framework that lets different organizations connect and exchange data seamlessly. And it's expected to become an official international standard very soon. So the protocol builds on the ISO Open Standards Interconnection Model, the OSI model, which defines how systems communicate across networks in a consistent, interoperable way, ensuring technical compatibility across multiple organizations and infrastructures. So as shown in the figure, multiple organizations connect through the connectors, which rely on the protocol to manage data exchange, supporting a unified schema and consistent HTTP-based communication. So interoperability is practical, not just theoretical. Now this slide emphasizes that a database is not just a technical implementation. So this is from the Dataspaces Support Center in Europe, and it shows that dataspaces bring together several interconnected dimensions: business, governance, legal and technical. So in this model, governance and legal aspects sit at the core, defining the trust, rules and compliance frameworks that make collaboration across organizations possible. So once those foundations are in place, the technical implementation builds on top of them, and that provides the tools and the infrastructure needed to put these principles into practice. So the dataspaces operate as a holistic ecosystem that unites policy, governance and technology. Now we'll move on to the ARDC Dataspaces pilot projects and give a bit of an overview of those. So the ARDC, or the Australian Research Data Commons, commenced 3 Dataspaces pilot projects a couple of years ago to explore how the Dataspaces concepts could be applied within the Australian context. So the first is the SEAF dataspace, and that was focused on environmental data and improving how environmental research data is shared and accessed. The second is the Biosecurity dataspace, which supports collaboration and the data sharing around biosecurity risks within Australia, which is an increasingly important area for national preparedness and response to biosecurity risks. The third pilot is a proof of concept testbed developed in response to a lot of community interest in having a hands-on example to trial database concepts locally. So ARDC is building in partnership with RMIT University as a prototype demonstrating how dataspaces could operate within Australian infrastructure and apply governance, local governance settings. So for the rest of this presentation, we'll focus mainly on the Dataspaces Testbed project, which has reached completion. The SEAF and Biosecurity pilots are still progressing currently. So the testbed has 2 main objectives. The first is to develop a database prototype tailored to the Australian landscape, and second, to test how the core components and standards perform in practice. So the team didn't start from scratch when building the testbed. Instead, they built on mature frameworks developed by IDSA, and the IDSA is made publicly available templates, patterns and technical resources, including GitHub repositories that could be adapted, with the goal of taking these foundations and contextualizing them for Australia. A second key object was integration with existing national research infrastructure. Australia's already got strong systems such as the AAF, the Australian Access Federation, used for authentication, the Research Data Network, the RDN, and RVA for data cataloging and vocabulary services. So the testbed was designed to interoperate with these rather than sit as a completely separate system on its own. RMIT's led this work and has done an excellent job developing the prototype. Brief demo videos are available to show what the testbed looks like in practice and how the different components fit together. Now, it's also useful to outline the broader plan for the Dataspaces pilot project, which has been developed in 2 phases. So phase 1, which concluded at the end of last year, focused on the exploration, preparation and implementation of a proof of concept here in Australia. So as mentioned before, there were no previous active examples or use cases of dataspaces in the Australian context. So this phase is focused on adapting and contextualizing established European models and frameworks for Australian infrastructure, governance and research environments. Now that goal has been achieved through developing and testing, a proof of concept prototype, which is a first step in showing that dataspaces can work within the Australian ecosystem. Looking ahead, we will be investigating phase 2, which is planned over the next couple of years, and that will build on the foundation of phase 1. So the aim is to expand the proof of concept into an operational environment, integrating real-world use cases and onboarding more participants and data partners to test the scalability and move from a pilot into a tangible value across the research community. So it's also a good point to highlight the valuable resources and frameworks from the IDSA, that can be directly adopted and adapted to Australia. So IDSA provides a comprehensive list of wiki documents, standards, templates and frameworks covering many aspects of dataspace development, including a detailed rulebook on governance patterns and guidance, which is particularly relevant given the global focus on dataspace governance. So these resources are already being locally applied. For example, SEAF is working with the European organisation 1001 Lakes to contextualise a rulebook and adapt the governance framework to the Australian regulatory and organisational environment. IDSA also publishes the reference architecture model, which is sometimes called the RAM, which offers guidance on building the different building blocks of a dataspace, both within specific sectors and across domains. In addition, IDSA also maintains an open source reference testbed that supports implementation and validation, and instead of developing everything from scratch, the Australian testbed has leveraged these widely adopted European components and adapted them for compatibility within the Australian context and needs. So this slide shows the architecture of the dataspace testbed with a focus on the main components and how they work together. So as in previous examples, there's two key parties, a provider and a consumer, and the goal is to show how data can be exchanged securely by following the principles defined in the dataspace architecture. On the provider side, connector A publishes data offers into a catalogue, shown as the broker in the diagram. On the consumer side, the participant searches the catalogue to discover data sets, but before accessing any offers, the consumer must authenticate their identity. Authentication is managed through the DAPS, the Dynamic Attribute Provisioning System, at the center of the diagram. So once both parties are authenticated and trusted, data exchange can happen securely between them and using the dataspace protocols and the connectors. So there's a lot of technical detail in this architecture. So for anyone wanting to explore it further, there's a QR code on the slide that links to more detailed documentation showing exactly how the components interact on both sides. Now, in this project, RMIT and ARDC work together on two main objectives: developing a dataspace testbed service and creating a dataspace dashboard. So the dashboard was designed to be accessible not only for technical users but also for those without deep technical knowledge or expertise, and provides a user-friendly, simple interface to set up dataspaces through a point-and-click sort of process. So using the dashboard, organisations can configure their own dataspaces, connect with partners and begin exchanging data securely with minimal setup and effort. So this slide shows what the dataspace testbed dashboard looks like. The dashboard provides several key capabilities. One feature lets data providers publish their data offers. Another feature allows providers to set usage policies that control how and under what conditions their data can be accessed. So a provider might, for example, allow only a specific purpose, or might only allow for specific purposes or for certain user groups, and the dashboard makes it easy to define and manage these policies. The role of the broker is also visible, so acting as a catalogue for all data offers in the testbed, and consumers can search the catalogue, discover relevant data sets, and send access requests to data owners, with each request governed by predefined policies or contracts. So here the focus shifts to policy classes, which are critical in defining how data can be used within a data space. Data policies let the data providers apply specific controls. For example, policy might state that data can only be used within Australia, ensuring that it doesn't move across borders. The IDSA defines 21 standard policy classes. In the current proof of concept testbed, 8 of these have been implemented, providing a practical starting point and demonstrating the flexibility of the framework, with plans to expand to all policy classes over time to give providers even greater control and precision over access and reuse. This slide demonstrates how dataspace principles support cross-cloud data exchange. So in the example, a data provider hosts datasets on AWS, for example, while consumers might operate in Azure or Nectar. And through the dataspace testbed, these parties can exchange data seamlessly as long as they can comply with agreed usage policies and contracts. The key point is that data doesn't need to be on the same cloud platform to be shared securely. What matters is that both sides follow the same standard protocols and policy conditions. One of the major strengths of the testbed is multi-cloud interoperability. So in real-world scenarios, organizations often store and process data across different cloud platforms, and the goal was to make these systems make sure that they can connect without compatibility issues. By using IDSA frameworks and standardized database protocols, a common technical schema was established that allows participants on platforms like AWS and Microsoft Azure to exchange data securely, provided that the data provider has granted the appropriate permissions. So this shows how dataspaces can create a cohesive and interoperable data sharing environment across multiple infrastructures, reducing fragmentation and ensuring consistent standards are applied across the ecosystem. So these projects have led to several important lessons about developing dataspaces. So we've learnt quite a bit through the process. The first, a database can't be built by a single organization or community in isolation. A coordinated collaborative approach is really essential for building trust and ensuring the framework genuinely serves everyone involved. The team worked closely with community members across Australia to align on shared principles and to agree on common governance rules, because without that cooperation there's a real risk of creating more siloed or disconnected platforms, which is exactly what dataspaces are trying to avoid. Another key lesson concerned the technical side of things. Initially it was assumed that the governance and the policy design would be the most complex aspects, with the technical implementation relatively straightforward, but the reality was in practice that the technical setup provided far more resource intensive and time consuming than expected. So these experiences have provided useful insights into both the challenges of establishing a proof of concept and what's needed to scale dataspaces successfully in the future, and that'll be really useful information for us in phase 2 of the project. Before finishing, it's worth mentioning how people can stay up to date or get involved with the Australian dataspaces. So you can sign up for email updates, which are sent about once a quarter via the ARDC website using the URL on the slide, or by visiting the site and searching for Australian dataspaces. For those serious about implementing a dataspace, the team would very much like to hear from you. There are monthly roundtables for the Australian Dataspaces community practice, which forms part of the Australian Dataspaces Implementers Network. And that brings together practitioners, researchers and organisations working on dataspaces initiatives across the country. So each month the members share experiences, explore challenges, and discuss practical solutions, many of which align with the topics discussed today in the webinar. And experts are also invited to share insights from ongoing database developments, helping connect Australian efforts with the broader international community. So if you're interested in joining a network, more details and registration information are available via the QR code on the slide, or just do a search for the Australian Dataspace Implementers Network. Thank you for your time and interest in Australian Dataspaces journey, and we look forward to continue the conversation with you in the future.